Hello and welcome to another video for pre-calculus. This is the part one of solving trigonometric equations. So let's look at the first example. So solving trigonometric equation means we are going to find the value of the variable where in this case the variable is x. So we'll find the value of x. So basically that would be an angle. Okay. So here is same as solving any algebraic equation. So we'll isolate the x and then we'll find the value of x. So first thing that we are going to do here is we'll subtract this square root of 3 from both sides, and then that gives us 2 cosine x equals negative square root of 3. And then if we divide by 2 on both sides, so we get cosine x equals negative square root of 3 over 2. Now we want to find the exact value, so we'll use the unit circle. So if we look over here, the cosine is represented by the x value in the unit circle. So negative square root of 3 over 2. So cosine is negative in the second and the third quadrant. So negative square root of 3 over 2 is right here, which is 5 pi over 6 or 150 degrees. And the other one is right here. So these are the two possible values in one period. So when it says one period, it's same as saying the first revolution. Okay, so it is from 0 to 2 pi, or if we are writing in degrees, so this is from 0 to 360 degrees. So that's the interval, which is one period for the cosine function. So in one period, the solution is x equals, so 5 pi over 6, and the other one is 7 pi over 6. Or if we are writing in degrees, we can write 150 degrees and 210 degrees. So these are the solutions in one period. Now the second question, the second part of the question is find all solutions, because we could have infinitely many solutions here because we have this solution, and if we go around and come back here, we have another angle, but it still represents the same solution, solution of that equation. That it keeps we can keep going around and round and round. Also, we can go in the negative direction, and we can generate as many solutions as possible. And we know that the graph of cosine function is like this, and we have infinitely many x-intercepts. So now to write the general solution, what we do is, so for example, let's take the first solution here, which is 5 pi over 6. Okay, so this is the solution. Now if we go around, or if we go 2 pi, then we come back to the same solution. And then if we go around again, that is if we go 4 pi, we get back to the same solution. So if we keep doing that, so we have 2 pi, 4 pi, 6 pi. So that this is what we are going to add to this angle. So in general, we can write this as, so x, so all solutions, okay? So in general, we can write x equals, so 5 pi over 6 plus 2 pi times n, okay, where n is an integer. So for example, if I take n equals 0, I have the first solution, which is 5 pi over 6. Then if I take n equals 1, then I have the second solution when I go around and come back to the same one. That is, if I add 2 pi. Then if I take n equals 2, that is adding 4 pi. That means I go around twice. Then if I take n equals 3, that is 6 pi. I'm adding 6 pi, which means I'm going around 3 times. Okay. Similarly, if I take n equals negative 1, then I'm going in the opposite direction and I'm going one round. If I take n equals negative 2, that is going around twice in the negative direction. So in that way, we have infinitely many solutions of that form. Okay, so 5 pi over 6 plus 2 pi n. Similarly, for the other angle, we have 7 pi over 6. We do the same thing, 7 pi over 6 plus 2 pi n, and n is an integer for both of this. Now, if we are writing that in degrees, okay, we can also write our solution in degrees. So if we are writing the solution in degrees, then this is what we write. So x equals, so we have 150 degrees plus 360 degrees times n, which is same thing as writing 2 pi times n in terms of degrees. Or the second one is 210 degrees plus 360 times n. So that's how we write the solution, all solutions in degrees and all solutions in radians. And this is the solution in the interval 0 to 2 pi or 0 to 360 degrees. So let's look at another example. So we are going to add 1 on both sides. So that gives us 4 sine squared x equals 1. If we divide by 4, we get sine squared x equals 1/4. And when we take the square root, so we have sine x is equals positive negative 1/2. So sine is positive in the first and the second quadrant. So that means if we are writing, so I'm just going to write the solutions in radians now. Similarly, you can write the solutions in degrees. So if I'm taking one period, or if I'm taking from 0 to 2 pi, okay, the solution in that interval is if I take 1/2. So sine is 1/2 at this value. So 1/2 at pi over 6, and then the 1/2 at 5 pi over 6. So this means x equals pi over 6 plus 5 pi over 6. Then when I take the negative values, the sign is negative in the third and the fourth quadrant. So sine is negative 1/2 at 7 pi over 6, and then negative 1/2 at 11 pi over 6. So the two solutions that we have are 7 pi over 6 and then 11 pi over 6. Now if I have to write this, the general or all solutions, then I will exactly use the pattern that I used in the previous example. So x equals pi over 6 plus 2 pi n, x equals 5 pi over 6 plus 2 pi n, x equals 7 pi over 6 plus 2 pi n, and x equals 11 pi over 6 plus 2 pi n, where n is an integer. Okay, so these are the solutions. So now here let's do the same thing. Let's go ahead and solve this equation. So first we are going to subtract 1. So minus 1 minus 1. That gives us 1/2 sine theta equals 0.38. Now we'll multiply by 2 on both sides to get rid of that 1/2. Okay, so that gives us sine theta equals, so 0.38 times 2 is 0.76. Now in order to find theta, we'll take the inverse sine function, which is sine inverse of 0.76. Now this one we cannot find it in the unit circle, so we are going to use a calculator. So we are writing solution in 0 to 2 pi, so that means we need to make sure that the mode of our calculator is in radian. And if we put that in, so this is what we are going to get. Okay, so theta equals 0.8633, which is the angle in the first quadrant. So that is the value in the first quadrant. Now, sine, this is positive, which means we have the value of theta in first and the second quadrant, okay? So in the first quadrant, this is the value. So in order to find the angle in the second quadrant, what we do is we subtract the value of the first quadrant from pi, okay? So pi minus the value in the first quadrant gives us the value in the second quadrant. So another value of theta is pi minus 0.8633, which is 2.2783. Now, the solution in the interval 0 to 2 pi. So these are the solutions. So in 0 to 2 pi, okay, these solutions are theta equals 0.8633 and 2.2783. Now, to write all solutions, theta equals, we just do the same thing that we did earlier, so 0.8633 plus 2 pi n, and the other one is 2.2783 plus 2 pi n, where n is an integer. Let's look at another example. Here we have this terms in two sides. So what we do is we'll isolate tangent theta. So we'll take this one on the other side, which means we'll subtract 5 tangent theta. So minus 5 tangent theta and minus 5 tangent theta. And that gives us, so 8 minus 5 is 3. Tangent theta equals 3 square root of 3. So if we divide by 3, we get tangent theta equals square root of 3. Now we know that tangent theta is positive in the first and the third quadrant. And the value of theta when tangent theta equals 3, square root of 3 is pi over 3. So it's this one. And then 4 pi over 3 or 240 degrees. Okay. So that means from here, theta equals pi over 3 and then 4 pi over 3. So this is the solution. Okay, so these are the solutions in 0 to pi in that interval. Now all solutions is given by, so theta equals pi over 3 plus, so we can do two things here. Either we can write pi over 3 plus 2 pi n, and then theta equals 4 pi over 3 plus 2 pi n. We can write it this way. Also, we can also write this as theta equals pi over 3 plus pi n. What does that mean is, so we have pi over 3 here, and then we have 4 pi over 3 here. Okay, so we have pi over 3. Now if we add pi, we get to the second solution here. Then if we add pi, then we go to the next one, and if we add pi, we can keep adding pi, multiple of pi, and we get to those two solutions. So we can also write this one in this form, okay, where n is an integer. We can do that, or we can also write it in this way. Either one is okay. Now let's look at this one. Here we have to factor and find the solution. So if you look at this equation, we have 2 sine theta cosine theta, and we have cosine theta here equals to 0. So what we are going to do is, this is similar to if you have something like 2xy plus x equals 0, and if you have to solve for x and y, so we just factor out x. So it's very similar to that, okay? So we have this cosine theta and cosine theta, so we can factor that out, so which is cosine theta times 2 sine theta plus 1 equals 0. And then from here, we have cosine theta equals 0. And from here, we have 2 sine theta plus 1 equals 0. So cosine theta is 0. Okay, so cosine theta is 0. So we're writing this in degrees. So just make sure you always read the question. Okay, so cosine theta is 0 at 90 degrees and 270 degrees. So it is 0 here and 0 here. Okay, so that is when the cosine theta is 0. So now from the second equation, we get sine theta equals, so we subtract 1 and then we divide by 2, so we get negative 1/2. So we know that sine theta is negative in the third and the fourth quadrant, okay? So it is negative in the third quadrant in the fourth quadrant. But we know that sine theta is 1/2 when theta is pi over 6 or 30 degrees. So to find the angle in the third quadrant, so sine theta is negative in the third and the fourth quadrant. So to find the angle in the third quadrant, um, we do 180 plus 30 degrees, or we can just look at the unit circle. We don't have to do that here. So it is this one, 210 degrees. So from here, theta equals 210 degrees. And then the other one is in the fourth quadrant, which is 330 degrees. So theta equals 330 degrees. So now we can write this is the solution. So solutions in 0 to 360 degrees. So in that interval, the solutions are theta equals 90 degrees, 210 degrees, 270 degrees, and 330 degrees. Now, so all solutions are theta equals 90 plus. So again, we have 90 and then we have 270. So we can either do 90 plus 2 pi n and 270 plus 2 pi n, or we can put these two together, 90 and 270, and we can say that this is 90 plus pi n, which means when we add pi, sorry, we're not going to write pi, we have to write 180. So 180 degrees n, which means 90, if we add 180, we get to 270. Then if we add 180, then we get to 90. And we can do the same thing in the opposite direction as well. So we can just write 90 plus 180 n. So that takes care of 90 and 270. Then we have the other one, which is 210 degrees plus 360 degrees times n. And then the other one is 330 degrees plus 360 degrees times n. So these are all the solutions. The first one, if we want, if you can write it that way, you can also write theta equals 90 plus 360 n, and then theta equals 270 plus 360 degrees. And we can also write it that way, but we can combine these two and just write 90 plus 180 degrees times n, okay, where n is an integer. Let's look at another example. Here again, we are going to solve this by factoring. So we can factor out tangent x here. So we have tangent x, then we have cosecant x minus 2 equals 0. And then from here we have tangent x equals 0, or cosecant x equals 2, because we have cosecant x minus 2 equals 0, which means cosecant x is 2. So from here we get x, so tangent x equals 0 means tangent is 0 at 0 degree and at 180 degrees. So this is 0 degrees and 180 degrees. And then here x equals, so cosecant 2 means it is same as sine x equals 1/2, because cosecant is the reciprocal of sine. So sine is 1/2 in the first quadrant at 30 degrees and in the second quadrant at 150 degrees. So 1/2 here and then here. So that means from here x equals 30 degrees and then x equals 150 degrees. So one thing very important here that we need to do is so whenever we have these two different ratios here, okay, we have tangent and we have cosecant. So here we got tangent x equals 0, or we got x equals 0 degrees and 180 degrees. So we really need to check that whether it works for that equation or not, because cosecant is undefined at 0 and 180 degrees. That means this value does not work for this equation because cosecant is not defined at those values, which means this is not possible. We cannot take that as the solution. The only solution is this one, because this works for that equation, okay? We can have a value for tangent and cosecant at 30 degrees and 150 degrees. So that means the solution, okay, so the solutions in 0 to 360 degrees. So in that interval, the solutions are x equals 30 degrees and 150 degrees. And then all solutions or the general solutions is represented by x equals 30 degrees plus 360 degrees times n, and x equals 150 degrees plus 360 degrees times n. So these are all solutions. Now let's look at another example here. So we are going to solve this equation, find the solution in 0 to 2 pi, and then find all solutions. Now if you look over here, we have a quadratic, and then we have sine. So this is just like a quadratic equation, okay? So this is just like looking at 2x squared minus 5x plus 2 equals 0. So how do you solve this quadratic equation? One thing that we really need to pay attention is sometimes you might have similar equation like 2 sine squared theta minus 5, and you might have cosine theta plus 2 equals 0. So this is not an obvious, it is a quadratic equation, but it is not obvious that we can factor and solve this one because these are not same. We have sine and we have cosine. It's just like you have 2x squared minus 5y plus 2 equals 0. So you don't have the same variable. So if we have something like that, we have to change the sine squared theta. We have to convert that in terms of cosine. So we have the whole equation in terms of cosine so that we can either use quadratic formula or do the factoring and solve it as a quadratic equation. We'll see this type of questions in the next video, but the one that we have here, they have same variable, they have same function over there. So we can just treat them like a quadratic equation and we can solve either by factoring or by using the quadratic formula. So this one we can easily factor this. So if you take 2 sine square theta minus 5 sine theta plus 2, or this is same as I said, 2x squared minus 5x plus 2. So we can factor this as x minus 2 and 2x minus 1. So similarly, this can be factored as sine theta minus 2 times 2 sine theta minus 1 equals 0. Now from the first part, from this factor, we get sine theta equals 2, and sine theta cannot be greater than 1. So we know that already. So this means this one is not possible. Okay, so sine theta cannot be greater than 1. So from here, if we set that equals to 0 and solve for sine theta, so we get sine theta equals 1 half. And we know that sine theta is 1 half. In the first quadrant, add pi over 6. And in the second quadrant, add 5 pi over 6. So that means from here we get theta equals pi over 6 and then 5 pi over 6. So that is the solution in the interval 0 to 2 pi, okay, in that interval. Now all solutions can be written as, so all solutions can be written as theta equals pi over 6 plus 2 pi n, and theta equals 5 pi over 6 plus 2 pi n, where n is an integer. So let's look at one more question for this video. So similarly, just like the previous question, we have a quadratic equation here. So we have 2 cosine squared x and we have cosine, and then we have 2 on the other side. So first, let's go ahead and move that 2 on the left hand side and rewrite this equation as 2 cosine squared x minus cosine x minus 2 equals 0. Now we cannot factor this, okay? So if we cannot factor this, then we have to use the quadratic formula. So cosine x equals, so negative b means the coefficient of cosine is -1, so negative b means it's 1 plus or minus square. So here if you want to write a is 2, b is -1, and then c is -2. So a is 2, b is -1, and c is -2. Okay, so 2, -1, and -2. And when you put that in the quadratic formula, so this is -1 is squared, which is 1, minus 4, a is 2, c is -2, over 2 times a, which is cosine x equals 1 plus or minus square root. So this is 1, so -4 times 2 is -8 times -2 is positive 16 plus 1 is 17 over 4. Okay, so from here if we separate this we get cosine x equals 1 plus square root of 17 over 4. And then we get cosine x equals 1 minus square root of 17 over 4. Now if we put this into the calculator, we get cosine x equals, if we put this into the calculator, we get 1.28077, and that keeps going on. So what we know from here is cosine x cannot be greater than 1, so this is not possible. Okay, so we just ignore that. Now we'll just take the other one and we'll put that into the calculator. So if we put this into the calculator, what we get is we get cosine x equals, so if we put this into the calculator, we get negative 0.78077. So that means x equals the cosine inverse of negative 0.78077. And then that gives us 2.4667. Okay, so now this is the angle in the second quadrant. So we know that cosine is negative in the second quadrant and the third quadrant. So it's a little bit tricky here. Okay, so in order to find the angle in the third quadrant, what we need to do is first we need to find the reference angle. So the reference angle is given by, so this is the angle in the second quadrant. So the reference angle or the acute angle in the first quadrant is given by pi minus this 2.4667. And then that gives us a pi minus 2.4667 gives us 0.6749. And then to find the angle in the third quadrant, what we have to do is we have to do pi plus the reference angle, which is 0.6749. And that gives us x equals 3.8165. So this is the angle in the third quadrant. So we have two values. This is in the second quadrant and this is in the third quadrant. So let me write it here. So in the interval 0 to 2 pi, the solution is x equals 2.4667 and x equals 3.8165. And for all solutions, okay, what we do is x equals 2.4667 plus 2 pi n, and x equals 3.8165 plus 2 pi n. So this is all solution, and this is the solution in the interval 0 to 2 pi. So we'll just stop here for this video. I'll come up with another part of this solving trigonometric equations where we have to use identities. We'll look at multiple angles and so many other things, okay?